the students of class 9, and as we are nearing the completion of the chemistry syllabus, like I was discussing in the previous class about the numerical problems related to your mole concept and the number of moles. So I'd like to continue with this numerical problems as just to refresh you how do we represent, what are the symbols which represents the different terms, like number of moles is equal to n, right? Then the mass is given as written as small n. Then molar mass is equal to capital M. Then number of particles is equal to capital N, and Avogadro's number is equal to n naught. So these are the symbols which represents the different terms, and that is why and this is only for refreshing you all, and you have to remember that these terms are always fixed, you cannot change it. So when these terms are being written, so you will be knowing that it relates to that, means when the letters are being written in that manner, then you will have to know that these are the terms which is being related to it. So next is that what are the relation between the different terms, that is like if you have to tell that if you have to relate the number of moles along with the molar mass and the given mass, then what will be the relation? N is equal to small n by capital M, right? Then the number of moles, if you have to write in related to the number of particles and the Avogadro's number is equal to n by n naught. So these are the two relation between the number of moles with the molar mass, or the number of moles with Avogadro's number and the number of particles. So moving ahead with our discussion about the numerical. So we will be discussing about now some more numerical problems related to the number of moles and the Avogadro's number. So suppose you have to calculate the mass of 0.5 mole of nitrogen. You have to calculate the mass of 0.5 mole of nitrogen. Here you see that it is N2, right? So the nitrogen gas, so it is N2. That is why you have to find out that means you need to find out the mass of 0.4 mole of nitrogen gas. Now what is the, now as you know that mass is given by what? You had your relationship, no? That is the molar mass into the number of moles. Right? So that means here you have to find out the mass, the relation is, as you know, that n is equal to, as you had this relation, n is equal to small m by capital M. That means here number of moles into, if you cross multiply, number of moles into molar mass is equal to the mass. So here the relation goes on. So the relationship is being established over here, and then what happens here is that you have to, what is the molar mass. It is for nitrogen, it is 14 gram. So that is why it is 2 atoms are there. That is why it will be what? It will be 14 into 2 is 28, and number of moles is given as 0.5. So that means it is equal to 14, right? So it is 14 gram. So that when you have to calculate the mass of 0.5 mole of nitrogen gas, that means mass is given by the relationship molar mass into the number of moles, and since there are 2 atoms of nitrogen, so 14 into 2, that means molar mass will be 14 into 2 into 0.5. It is given that this data is already given 0.5 mole. So if you multiply 28 into 0.5, that means it is equal to 14 gram. So the mass of nitrogen gas for 0.5 mole is equal to 14 gram. So moving ahead, I hope you have understood. So next is you have to suppose you have to calculate 0.5 gram of nitrogen atom, 0.5 mole of nitrogen atom. So here what is being given? Nitrogen atom. That means there is only one atom. So similarly, what will you get? So as the relationship is being established, so what happens here is M into N, right? So here what is M? It is 14 because there are only one atom of nitrogen. So if you multiply by the number of moles is equal to 0.4, so that will give you 7 gram. So here that means you just see the difference. In the previous numerical problem, it was written as N2. That is why we multiplied it by 14 into 2, that was 28. Now since it is only nitrogen atom, that is why we have written it as 14 into the data is already given, number of moles is equal to 0.5, so that will give you 7 gram. So I hope you have understood. So again, if you have to calculate the mass, of 3.011 into 10 to the power 23, 3.011 into 10 to the power 23 of nitrogen atom. So what you will do is that the number of moles is given by, as you know that number of moles is given by number of particles by Avogadro's number, no? So that means what you have to do is that here it is given, the number of particles is given as what? 3.011 into 10 to the power 23, and M naught you know it as Avogadro's number, that is 6.23 into 10 to the power 23. So approximately what it becomes, here I have missed out, that is M into N, no? So what will is equal to N by N naught, so that will give you 3.011 into 10 to the power 23 by Avogadro's number is 6.023 into 10 to the power 23. So what happens is that we know that M is equal then that is the M is equal to, we know that M is equal to what? Capital M into N. So that will give you what? It will be, so that will be 14 into, we put the value of this N, so it will be 3.11 into 10 to the power 23 by 6.023 into 10 to the power 23. So as you do the calculation over here, it will be almost 0.5, 14 into 0.5. I put it over here. That is 14 into, if you cancel, it is almost equal to half. So that is half means 0.5. So that will give you 7. So that means the 7 gram. So that explains you that means here you see the number of moles is equal to n by n naught. So that will be equal to number of moles is given as 3.011 into 10 to the power 23, and Avogadro's number is 6.023 into 10 to the power 23. So that means we know that m is equal to molar mass into number of moles. So molar mass is equal to, we know that for it is nitrogen atom, that is why it is 14 into how much, you put the value of n here. So what happens here is that this goes cancelled, it is almost equal to 0.5, and then because it is half, and 10 to the power 23 and 10 to the power 23 will get cancelled. So 14 into half means 0.5, so that gives you 7 gram. So here I end my class here, and and your chemistry syllabus is almost complete. I hope you all are having the better concept, and if you have any problem, do come up in the Zoom class. Thank you very much.